Hello and welcome. In this video we're going to be talking about the required practical on titration. Now the most important thing to understand is this concept of neutralization. So this happens when an alkali and an acid react together and it gives us salt and water. In this case I've got sodium hydroxide plus hydrochloric acid giving us sodium chloride and water. Now titrations can be quite useful because we can use this technique to work out the concentration of acids or alkalis. So for example, suppose I do not know the concentration of an acid. I would put this acid in the conical flask as shown in this diagram. The alkali, of which I know the concentration, will go into this glass tube here, this long glass tube called a burette, and I can just open the tap and react this alkali with the acid, and as soon as that acid becomes neutralized, I can stop the burette and read the volume of alkali that was required to neutralize that acid. Right, so I know that was quite fast, so I'm going to try and make it a little bit clearer in this next part of the video what's happening. So what we're doing is we're trying to react this sodium hydroxide, the alkali, with the acid in the conical flask. Now the concentration of the acid is unknown, so that's why it's in the conical flask, but the concentration of the sodium hydroxide is known, and that's why that's in this burette. Now what will happen here is a type of reaction called neutralization, and when the pH hits 7, the color will change to a pink color and the conical flask will start to look like this, and that tells us that the pH of that solution is now neutral, and we can stop adding more sodium hydroxide, and then we can read the burette to find out the exact volume of sodium hydroxide that was required to neutralize that acid. And that's it. So now we're going to go through the equipment that is required to carry out a titration. So the first thing I'm going to go through is this long glass tube over here. This glass tube is called a burette. Now in my experiment I'm trying to work out the concentration of an acid, and that means I need to know the concentration of the alkali, which means the alkali needs to go into that burette. The acid of unknown concentration will have to go into the conical flask over here. Now to measure out a fixed volume of the acid, I'm going to be using this glass apparatus here called a pipette. This particular one can measure out 25 centimeters cubed, and you would know that you've reached that volume once your acid or your liquid hits that line over there. Now to draw up the liquid into that pipette, you would need to use a balloon filler, and it's you just simply squeeze it, and then that vacuum that's created will then draw up the liquid into there. Obviously you need to put this on top of or attach it to the pipette first. We also need an indicator. I'll tell you why this is important in a second. If you look at the alkali, it's colorless. If you look at the acid, it's colorless. When they react in a neutralization reaction, all the products are still going to be colorless, which means we won't know exactly how much alkali was required to neutralize the acid. So we need to use an indicator, and that indicator just changes color to let us know when the acid has become neutralized, so we can stop pouring more alkali into that conical flask. Now you'll notice I've also put a white tile over here, and this white tile just helps us see the color change more effectively, because sometimes the color change can be quite faint, so that just makes the experiment more accurate. So here are my results. I've repeated the experiment several more times to get a total of 4 results. Now it's a good idea to repeat this experiment a few times because it makes your results more reliable. Now you'll notice result number 1, the volume of sodium hydroxide required was 13.50. This is very different to the result number 2, 3 and 4, which tells us that result number 1 is an anomaly and we can ignore this. If you remember in the video, this is the one where I added too much alkali way past the point of neutralization. So this result is definitely inaccurate. So we can ignore this from our mean calculations, and we're just going to use result number 2, 3 and 4. So we're just going to do 12.10 plus 12.05 plus 12.10, and then just divide that by 3. And if you give the answer to 2 decimal places, you should get 12.08 centimeters cubed. This was the average volume of sodium hydroxide that was required to neutralize that acid.